This video is purely an example video of what would be considered to be a hard related rates problem. Here's the problem statement. The problem says that a conical tank with vertex down is 10 feet across the top and 12 feet deep. If water is flowing into the tank at a rate of 10 cubic feet per minute, find the rate of change of the depth of the water when the water is 8 feet deep. Oh my gosh. Alright, let's try to break this up into a bunch of things before we freak out. So, what's our first step for any related rate problem? Great, draw an accurate picture. Conical means cone, and the vertex, which is the tip, is down. So we have a picture. There's the base of the cone, or the top rather, and there is the vertex, and that's the center of the circle on the top, and it tells us that the thing is the cone the cone is 10 feet across at the top and 12 feet deep. Very nice. And water is flowing into the tank, so we're like, yeah, here's some water going in the tank. Check out my artistic skills. And eventually we'll get to the point where the water is 8 feet deep, so that's like here-ish. Okay, warble, 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 there's the water. Yes, water does make the warble, warble, roll sound when it's in calculus. Great, and that's water in the tank. Awesome. So we've drawn a picture, pretty accurate. Yeah, that's water right there. Good old H2, good old H2O. Yep. Okay, cool. Step 2 was to identify which things are constant and which things are variable. Well, we don't have much in the way of variables because we haven't labeled our picture yet. Let's go ahead and label the picture. Now, so first off, 10, the diameter of the top and the height of the cone do not change. These are constant. That's an N and an S and a T. These are constant because the shape isn't actually changing. So this is also constant. But the height of the water, we'll call it H, which is really the depth, so maybe depth or height. I don't want to do D, because then we end up with like DDT, like DDT. Yeah, it just sounds kind of weird. So the height is definitely changing, and also if you think about it, the radius here of the water is going to change. And the reason that I chose height and radius is because of this sentence that appears in the problem statement. If the water is flowing into the tank at, wait for it, a rate of 10 cubic feet per minute. Hey look, that's a rate. That should clue us into this is a mathematical quantity. Cubic feet, that's the same as like feet cubed, and per minute means divided by minutes. So if I have feet cubed per minute, that's the same thing as volume over time, and this, my fellow students, not fellow students, this, my students, is going to be dV dt, because it's the rate of change of volume, which is feet cubed, with respect to time. So we know we're going to have to do something with volume, and because it's a cone, we're looking ahead to this formula, which says that V equals 1/3 pi r squared h. So that's why I chose h and r to be the variables, because that's like this, the blue, the watery stuff is forming a cone inside the conical tank. Hopefully that made some amount of sense. So yeah, that's where we're at. Let's go ahead and go to the next step. Well, we've basically already done that. We have some variables, right? We have r and h and v, and we've somehow related those three variables because it's a cone, and so we've gotten this equation, v equals 1/3 pi r squared h. Now, this is why this problem is special and different from the other types of problems that we've done. Read the rest of the problem, and let's see if we can pick out any other information. So, we got a vertical tank, and it's got that and that, so those are the constants we have. And we have dV dt here, and we want to find, the rate of change of the depth, or in this case h, of the water. Great, so that's a thing. And this thing, I'll write it over here, the rate of change of h with respect to time, we're looking for dH dt, like that, very nice. And then when the water is 8 feet deep, eventually, not right away, because then you're going to kill kittens, eventually we're going to plug in h equals 8 into the equation to get us the dH dt. Now, if you notice something, we have lots of green, which is the volume, and we have lots of blue, which is the height, mentioned in the problem statement, but where? Where is the radius involved? Uh-oh, we have a problem, sort of. Because nowhere does it tell us anything about r or dr dt. Why dr dt? Because when we differentiate this, eventually we're going to end up with a dr dt. So we need to address this issue at some point. Now there are two ways of doing it. I'll show you one way, because I think it's a little bit easier than the other way. So here's what we're going to do. Imagine that I lose my three-dimensional perspective and I'm just looking at the thing head on, and I've taken a cross-section of the tank. Recall that the top of the tank was 10 across. I'm going to split that so that this is 5 and this is 5. And then recall also that the height of the entire tank was 12. Now I'm going to relate this to our other variables. So we have h, which is the height, and r, which is this length here, because it's a circle. Remember, it's like that is how it really looks in three-dimensional life, but whatever, ignore that. So we have r. And then we have the equation v equals 1/3 pi r squared h. And the problem was that we didn't know anything about r. So here's one solution, and that is to find a different relationship between some of the other variables in the problem. Alright, now here's where things get kind of weird and you have to remember geometry, oh my gosh, and all that other stuff. So if you look at this, notice that this is a right angle and this is a right angle, and the two triangles here and here share this angle. So we have angle, angle, and then by default these two angles are the same. Angle, 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 we have similar triangles. Ooh, very nice. And so what this means is that the ratio of r divided by h is going to equal 5, which is the radius of the entire tank, divided by 12, which is the height of the entire tank. Okay, this is the key to this problem, and that's why it's a hard problem, because not only do we have to come up with, or have the original equation, but we need to supplement it with another equation. Oh my gosh. Just a note, on the AP exam, you will be given volume equations. Remember, the AP exam is testing your knowledge of calculus, not necessarily geometry, and so they're not going to make you memorize all the geometrical formulas. They will, however, expect you to know things like similar triangles. So, this formula will be given to you, but then you have to figure out how to use it with other stuff. So, because we're eventually looking for dH dt, that means I want to eliminate r from this equation. So what I'm going to do is I'm going to solve for r here and then plug it in to the other one. Let's go ahead and do that. Oh, great. All I have to do is just multiply h over, and so r equals 5/12 of h. Very nice. And now I'm going to plug that into my volume equation. So we get v equals 1/3 pi r squared, but remember r just changed to 5, or 2 lines, yeah, 5/12 h squared, and then we also have that h hanging out there at the end. Let's go ahead and simplify this before we take the derivative. You'll find that that's a lot nicer than having to do the product rule on something that you could just easily combine. So let's see, we got 5 squared. 5 squared is 25, 12 squared is 144, and then 144 times 3 is going to give us 432. Okay, funky fraction, but just go with it. So we have 25 pi over 432, and then the h's just combined to become h cubed, like that. So really, this volume equation isn't that bad, and in fact, we won't have to do anything like the product rule here. So let's go ahead and go on to the next step, which is take the time derivative of this thing. There we are, like that. Derivative of both sides. The left side is simply dv dt, which is very nice because there's nothing else going on there. And then the right side, well, we're going to use the that rule. Yeah, hold on. The power rule, and actually that number was a 432. So we're going to bring down the 3. So check it out. We have 25 times 3 times pi divided by, well, the 432 is really 3 times 144. So if you want to keep it like that, you can, because then the 3's just cancel. And then you have h squared, because we subtracted 1. And then, remember, the chain rule, d dt of h. So we have a dh dt. Do your quick check. Do you have a rate in each term? And yes, you do. You have dv dt and dh dt, so we're good. And now we basically can substitute in, this is the next step, substitute in the values. Let's go back and figure out and remember what dv dt was. Problem statement. Yeah, we said that dv dt was equal to 10 because it's increasing. Notice that the water is flowing into the tank. That means the water level is rising, so dv dt is positive. If water was flowing out of the tank, then dv dt would be negative, but that would be a different problem. So 10 equals 25 pi over 144 h squared. Well, let's go see what h was. Oh, there it is. H is 8 feet deep. So we have 8 squared times, oh, we're solving for that. We're still solving for dh dt, so that's going to stay like that. And then I'm just going to move everything to the other side. And the beauty about the AP exam, especially, is that you don't have to simplify answers. So dh dt is simply going to be equal to, let's see, on the top, we're going to have 10 times 144, so 1440, and on the bottom we're going to have the rest of that, so divided by 25 pi times 8 squared. That's a number. It's approximately 0.286, and then don't forget the units. dh dt, h is measured in feet, and in this problem the time was measured in minutes, and so that is the answer. Woo! Hey, stay tuned for a second. I'm going to explain the other way to do this problem, and it's sort of similar, but just so you get a feel for it. We go back to v equals 1/3 pi r squared h, and then this time, instead of doing that substitution, so remember we had the ratio that r divided by h was equal to 5/12 from our similar triangles. And so really we have the equation that r equals, let's see, 5/12 h. So we have this equation and this equation. And the second way of doing this related rates problem is a little bit trickier, but it does involve the product rule, and I want to show you how that works with related rates. So we take the time derivative of both sides of the volume equation before substituting. So we're not going to do that right now. We're going to take the derivative here. So we get dv dt, let's see, dv dt equals the derivative of 1/3 pi r squared h. Remember that both r and h are functions of t, and so you can't just treat them as constants. So now the left side is easy because it's just dv dt, and the right side I'm going to take out the 1/3 pi because it's a constant that's multiplied, so I have 1/3 pi. And then the inside of this is going to have to use the product rule because I have r squared times h, and r squared and h are both functions of t. So we have to use the product rule. Here's what it looks like. We'll have a 2r from bringing down the r, and then, don't forget, the chain rule. We'll have a dr dt come out, and then the second equation is going to be r squared times dh dt. And again, we have the chain rule. Really, it's the derivative of h is 1, and then you have the chain rule with dh dt. And do your check. Clearly, every term here does have a rate in it. So we have dv dt, we have dr dt, and dh dt. And now we're sort of stuck, because now instead of, like, we know h, but h is gone at this point. So now we have r to figure out and dr dt to figure out, and so now we have to look at this equation up here. And so now we could plug in h equals 8 to get us r. Okay, that gets us the value of r that we can plug in here. And that solves that problem. But in order to find dr dt right here, we have to take the time derivative of this equation. Oh my gosh. So we have d dt, so dr dt, and that's going to equal 5/12, and then the derivative of h with respect to t is dh dt. So yeah, there's a lot going on in this problem. If you choose to do it this way, I don't recommend it, obviously, because it's like 3 related rates problems, or 2. And so then you take this quantity and you plug it in for that, and then all the numbers, and then you end up with solving for this dh dt and that dh dt, and that's the unknown, so it's nasty. I'm not going to solve the rest of this problem. If you want to work it through, you can, but that's just an example of, hey, there's usually more than one way to do it, and in this case, this is the easier way, where you can recognize the similar triangles first and substitute it into the volume equation before taking the derivative. So hopefully we'll get some practice with difficult problems like this. Again, this was a hard example, so chances are you probably won't see these very often, which is nice.